Hello and welcome to another video, this time going through Statistics 2020 question 4, a discrete random variable question. Finally, I've got a discrete random variable question which looks more like the old ones which they used to do. And so if you want to practice these kind of questions, go to the old Stats 1 past papers. They definitely had questions like this. Go to the IAL Stats 1 past papers. They're good for these kinds of questions. They won't have anything on a large data set, which you'll probably be quite happy about, as I am. But they'll have questions like this. Now, yeah, they're not too bad, actually, although the last bit, I've gone through this with a tutee recently. It's not easy. But yeah, first bit, table of probabilities. What are probabilities in a table always add up to? Well, they add up to 1 because these are mutually exclusive events and one of these events is going to occur. Yeah, think of this as like, if you're ever confused with these questions, think of this like a spinner is being spun and you're getting these scores like after the spinner is spun with these associated probabilities. So we know that k over 10 plus k over 20 plus k over 30 plus k over 40 plus k over 50, and they're really annoying numbers here. Well, that should equal 1. Yeah, so we need to obviously add all of these together. Probably the easiest way would be to take this out and add all of those up like that. Yeah, and you can do this on a calculator naturally. And so k times by, let me just quickly add it up to see what you get. Well, 1 over 10 plus 1 over 20. I haven't got the wherewithal to actually work this out at the moment. Plus 1 divided by 50. Okay, I get 137 over 600, which is, by the look of it, good news. And so k is 600 over 137. Yeah, never get factorizing if you've got letters involved. It's a very useful trick. Okay, the random variables d1 and d2 are independent and each have the same distribution as d. Now you can think of this as a spinner being spun twice. Yeah, they want you to find the probability that after spinning the spinner twice, the sum of the scores is 80. That's the best way of looking at these. Yeah, they used to come up all the time in the old Stats 1 paper. So if you want to practice these kind of questions, go to the old Stats 1 papers and look for the DRV question, the discrete random variable question. Okay, so if we're doing this, we're going to be thinking, well, how can we make 80? Well, you could get 40 and 40. So we could say the probability, let's make this nice and clear to the examiner what we're doing. The probability that D1 plus D2 is 80. Oh, sorry, that's wrong. The probability that that's the case is going to be equal to the probability of getting D1 is 40 and D2 is 40, and D1 is the first roll or spin and D2 is the second roll. How else could we get it? Or we could have got 30 and 50. Or we could have done it the other way round, couldn't we? We could have had 50 on the first spin and 30 on the second. Now, is that the only ways of doing it? Probably. Let's have a look. Any other ways of getting 80? 20 and 60, 10 and 70? No, that's going to be the only way. So how do we deal with this? Well, if you're spinning a spinner twice, you need to multiply the probabilities. So we're going to have 600 over 137, that's k, multiplied by, well, 40 is 1/40th, yeah, because it's k times 1/40th. Oh, but then I'm timesing that by itself again. So I'm just going to square that. Plus, okay, then I'm going to have 30. Well, that's 600 over 137. It's just such a horrible number to use, that. Times by 1 over 30. And then I want 600 over 137 times by 1 over 50. Yeah, and the next one's going to be identical to this, but the other way around. So you could just say times 2 on the top one. But I'm just trying to do, I'm writing this all down just to show you, trying to show you it so it's nice and easy and you don't get confused. Why does that say 150 up there? Classic blunder. Over 30, yeah. Okay, and then we just work all of that out. But it's a long old question, it really is. It's easier if you've already worked out 600 over 137 as a decimal, that's for sure. And working this out on my calculator, I think I'm going to press 600 divided by 137 first, just so I've got that as a nice number and it's in my calculator's memory. And I can just say Answer over 40 squared. Look for shortcuts so you can do this quickly on your calculator. We'll see if I make a mistake because we'll check it with the answers in a second. Plus answer times by, well, answer squared times by 1 over 1500. And then I'm just going to times that by 2 because it's added to itself, times by 2. Okay, I'm getting 0.0376 to three significant figures, yeah? We'll check that in a second. Okay, a single observation of D is made. The value obtained, D, is the common difference in an arithmetic sequence. Look at this, they're putting in some pure in the stats. Good for them. I like that, I approve. In both the other examples, AQ and OCR, they mix up the stats and the mechanics with the pure paper. I don't know if you've noticed that. So they can definitely do this in their ones, and they do it in Excel as well. So watch out for it. The first four terms of this arithmetic sequence are the angles measured in degrees of quadrilateral Q. Lots going on here. So we're just spinning the spinner once, and the first four terms of this and the value obtained is the common difference of an arithmetic sequence. So this is going to represent the common difference, yeah? Now the first four terms of this arithmetic sequence are the angles measured in degrees of a quadrilateral Q. What is the exact probability that the smallest angle of Q is more than 50 degrees, yeah? So let's talk about what our angles are. Let's draw the problem, yeah? And let's call these angles X, yeah? Well, in that case, it's got to be X plus D. This would be X plus 2D. And this would be X plus 3D, yeah? And that's just because that's the way an arithmetic sequence works, because D is the common difference, yeah? And so if we were thinking about this, we'd say, well, straight away, well, 360 must equal all of these added together. And what does that add together to give? It gives 4X plus 6D, yeah? Cool. Okay. Now we want the probability that the smallest angle of Q is more than 50 degrees, yeah? In other words, we want to make sure that X is greater than 50, yeah? So if X is greater than 50, well, let's rearrange this to make X the subject. 360 minus 6D over 4 is X, yeah? My thinking is, and it's just the way I've come up with it this time, I think I did it similar when I did this intuition the other day, but if I want X to be more than 50, then I want 360 minus 6D over 4 to be greater than 50. In other words, times that across, 360 minus 6D is greater than 200. Add that over there, take that over there, 160 on that side, 60 on this side, and in the end I get D is less than, I'm just doing 160 divided by 6 on my calculator, I don't know why, D is less than 80 over 3, let's turn that into a decimal. We want D to be less than 26.6 reoccurring. Now, less than 26.6, that's just these two added together, so I've got to do 600, so the probability that D is less than 26.6 reoccurring is 600 over 137 times 1/10 plus 600 over 137 times 1/20th, and I'm just going to work that out now on my calculator. 600 over 137 times by, okay, I'm just going to do 0.1 plus 0.5, it seems quicker. Okay, I'm going to get 90 over 137 on my calculator. Okay, let's check those because, always check, yeah? Always check your answers. It's just good habit. Okay, yeah, this is fine. We got 0.0376. I did that one. Slightly nervous about that. There was a lot going on there. And then, okay, how did they do it? Consider cases. Okay, yeah, they didn't do it with inequalities. There we go. But my way's pretty sure it's perfectly valid. I ended up with 90 over 137, so I'm happy with that. And that's all there is to it. Yeah. Okay. Hope that makes sense. Keep up the hard work. Bye bye.